make an idiot of myself again. Right. So, I was thinking about vibe coding versus agentic engineering, or whatever it's called. In principle, I kind of should agree with agentic engineering, but I don't. It just doesn't work with me very well because as an artist, I have bottom-up approach. So bottom-up is different than top-down. What happens is I build small version of a system, quite detailed, but small, little, without any features really. And then based on that, I find dependencies and I start abstracting away, creating more abstraction, splitting components, making it more componentized, as opposed to going out of zero and having an architecture in my mind. I don't do that this way. So I need to have specification by example. That's what you do. So a source code that's empty, and you just write a few lines how you would like to, how you would like your program to be programmed. So some components, how you would like to put them together. Okay, is this stream going, is it? Not sure. Sounds like it might be. Let me just check quickly. Open Studio, where does it open? Oh, opens here. Okay, it doesn't actually open in, doesn't actually show it. I see. Okay. Let's do it this way. Anyway. Alright, let's keep going. So, submit public key. What are we doing? We're removing the thing because we don't need this anymore in the poker hand. Right, we don't need this anymore in the poker hand. Just check maybe something quickly on the other screen, just to make sure. I'm here. Okay. Okie dokie. So, yeah, I don't know. I don't trust Studio, whatever. Okay. So what are we doing here? We are removing the submit. Okay, remove submit. So now I can follow the process of doing all this, I think. It's still running, why? Okay. So I'm gonna rebuild this. Oh, I should ask Codex to change something. Settler. So yeah, so the signature. So okay, let's do that. I don't want this. I want in the yeah, this. There is number of parameters. I'm afraid this aggregate signature is only only of digest, and it should contain, should be a signature of all arguments. So should be signature of table ID, but there should be lobby ID as well. Lobby ID, table ID. By the way, lobby ID is missing. Yeah, so how could, no, there is a lobby ID. I just didn't copy it properly. Oh, I did. Okay, my bad. Hand ID. So it's kind of like scoped IDs. So table ID is per lobby. We need to find it in lobby. Pot size, pot split. And that should go from 0. So we're gonna the size of it, chip balances. Yeah, I think digest should have all this information. Well, I don't know. Let's do it this way. For now, I'll figure this out in a moment. Yeah, then digest. Where, yeah, okay. Well, worst case scenario be redundant. Yeah. Need to show that all players find those parameters. And here. And player who sends transaction isn't lying, isn't making them up. Okay, so and to verify lots of things like this. Oh well. So what's principled vibe coding? That's what I see it like. You know, I'm a principal engineer, so I'm engineering the principles of the system, and Codex is just doing the typing for me. You know, so Codex is replacing the whole dev team to just do some work for me. But yeah, I need to look in the code and figure out what else I want. Right, so settled hand should, yeah, as we said, should check all those in signature. So signature, where is the signature? Settlement signature digest. Oh, here we go. Now it's nicer. Digest 0. Yeah, so this digest is kind of maybe redundant with that, maybe not. It's some digest, additional data. whatever is the data, binary. It's a blob. So these are the essentials. So this is, we need to know which hand, which table, which lobby. We need to know how is it split. Yeah. Maybe we ask, okay, maybe we add ranks and suits. You know, digest. What do we put in digest? What kind of data? Okay, log by table, hand, pot size. It's a Keccak of all this. Framework for settled hand. Ah no, it's here. Okay, so that's a Keccak. But this yeah. So what exactly? Goes into it? It's a hash. It's interesting. Okay, all this, all the hand history and stuff like that. It's the whole gameplay. So it's a proof, it's a signed proof that the hand has happened. Okay, so, but we don't know what was the outcome. You know, we just have a hash and we just know how the pot was split, but we don't know who won, what was the cards. You know, maybe let's add that here so that, you know, let's change a bit. I want more info on chain. So pot size, chip balances, cards. So that's all cards for each player. How many? What do we put here? Maybe bytes, because it's gonna be yeah. Or maybe deck. Oh. Cards. Shuffled cards. Something like that. And that should be maybe vec. If it's a vec, it's not great. It's gonna take. Vec is bad. Because I would do vec of u8, but vec of u8 is not so amazing. Because each u8 will take you to 5-6 slot, which is wrong. Well, this is an argument, so maybe it doesn't matter. As long as it's not stored on chain, maybe it's fine. So yeah, the cards. As they would appear. In the deck. unmask cards as they would have appeared on the deck. Yeah. Okay. Maybe we don't need this. Maybe it's fine. Okay, I don't know. Just thinking. Let's leave it. So the whole transcript. Okay. 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 So verify signature call. Oh, that goes to verification. Here, digest. And we have this here. Digest to G1. And then we do multi-Miller loop. Okay. Makes sense. We call it hash to curve. This is kinda generator times scalar from byte to byte. Okay. But I think it should be hash to curve. This digest to G1. Hash to curve. And here we go. Right. Oh, hey guys, how are you? Guys or gals? So we're improving the cryptographic part. So the improvement is that Codex made a mistake here, and that's fine. I mean, I'm used to the fact that I have to ask Codex to do some changes. So the settle hand, so the protocol, the way it goes is, as a player, you go on blockchain, you call some smart contracts method to find a table to play, and you join that table. That's a smart contract call, right? Or you can make another smart contract call to create new table, right? So if you create a table, it's creating and joining, and if you join, just join. So on blockchain, you have two players who called one called create table, another called join table, and the state on the blockchain says these two players are at the table. Now the next thing is that I think each player calls start hand, and when that happens, blockchain records the fact that a hand on this table was started, and this is where interaction with blockchain ends, and we switch to peer-to-peer. So from that moment onwards, gameplay goes peer-to-peer, and then when the hand is finished, we submit the result on blockchain, because blockchain stores the state, so the chips are on blockchain. So players' chips, the balances of the chips, they need to be moved from one player to another, right? So the way it went was, actually they were moved when you bought into the table. Okay, the chips were moved when you bought into table. But then when you're playing a hand, you have balance of chips at this table. So each player gets those chips moved on the settle hand. Okay. Now, what we want to make sure is that the settle hand isn't just some smart contract call out of nowhere. We want to make sure that the players have agreed the outcome of the hand. So if they play the hand, they have agreed the outcome is who is the winner. Okay, and someone submits this message on blockchain with the signature, the aggregate signature, which confirms that all players agreed. The question: what happens when some player wants to cheat, doesn't agree to sign the message or anything like that? That's phase 2 of this protocol. But generally, I was thinking of booting that player. So if player wants to cheat, the player is banned forever. That's it. No more game for you. So you will submit, or you're out. And you lose all your chips and of course the dollars that you have deposited. So cheaters are immediately punished, to the benefit of those who stayed at the table, right? So that would be typical slash, as we call it. Now this needs to be worked on, and this version I don't have slashing implemented. But this is the simplest slashing you can have. I could be a little bit more forgiving, and also the reliability of this protocol. Do I trust the protocol? Will the protocol lose all the users because everyone will be detected cheating while they were just having difficulty with the protocol? So we don't want this. We don't want this to happen. So there is subject of research, right? This is research work. Yeah, so it's interesting. Now let's see what Codex did for me. So Codex, what was my query? Oh, I wanted to use hash to curve. Changed. Okay, so let's see what was changed. So hash to curve is something like that. So this comes from, this is Rust, and so if you wonder, this is not HD, this is 1440p, so this is high resolution. So this is the resolution at which I'm working. Now, there is this library in Rust, BLS12381. Actually, I can zoom it slightly in because I am conscious that people may not use such a high resolution. So I'm gonna zoom it in for you all who's watching. So now it should be fine on HD. So 1080p, you should be able to see it now. I'll do the same with terminal. Okay, and now everyone should be able to see it, I think. Okay, it's a little bit less comfortable to work with, but okay, let it be like this. So what I asked, I asked Codex to use hash to curve instead of the previous function. So maybe I can find, actually, because this is elliptic curve, right? So what elliptic curve looks like. So that's I'm sure I'm gonna find very easily BLS curve, or maybe even here on the Wikipedia. No picture. Maybe images. Yeah, so there is things here drawn. One of the fastest BLS signature. Yeah, but I think this is the one that's useful as a picture. I think so. Yeah, so the idea, like this picture shows here, oh, Bitcoin. So the idea is that this is the curve. It looks nice on this picture, but in reality, it's there is modulo, right? It's the numbers are huge. Those numbers are huge prime numbers, and the whole thing is modulo some. So sorry, the whole thing is modulo huge prime number, so it's very scattered. So this whole elliptic curve is like put through modulo operation. It doesn't look so pretty. So that's how it becomes difficult to go backwards. But anyway, even that curve is kind of interesting. And also, this is just two-dimensional curve, and the thing in that we use in this, it's 12 dimensions. So it's a little bit more complex than that. But just conceptually, if you have elliptic curve, then you have some point G on that curve, which is well-known point. So point G is well-defined. It's like constant, known by everyone. And then there is some, they say public key in this case, signature. So yeah, PK is PK to signature. So the distance between this G and this P, that is the result of multiplying this public key. Oh yeah, okay. P is public key. Yeah, this is secret. The PK is secret. So the way they put it on this picture is kind of confusing. But what's happening here is this generator point multiplied, and this multiplication is, I think, 12-dimensional operation or something like that. It's a complex thing to do. So this secret multiplied by this G yields a point, a public key, right? So we don't know, we cannot go from public key to the secret because we don't know how many times we need to multiply this G to get to this public key, right? We don't know that. Division is impossible here. But what we do know is that if we have hash to curve of some information, the signature of this hash to curve, so like if this is some hash, then this hash multiplied by this secret gives us signature. And what we do know is the distance, okay, or like kind of like distance between this hash and the signature on this curve is the same as this public key and this G. Okay, those two are kind of, well, there's a pairing function, so I don't know if like distance or what it is. It's kind of, there's this pairing function, right, which says this pair and this pair, they are, you know, how do you say? You can prove that if you have this pair and this pair, these two pairs are, the pairing function will be the same for them. Okay, the value of this E is the same for those. So that's used to you know, to verify signature. But the cool thing about BLS of this thing is you can accumulate multiple signatures. So because one signature is multiplication by someone's private key, so if you want to accumulate number of signatures, you just multiply, and multiplication is you can swap order, right? Commutative. So when you do that, the result, as you would expect, would be the same thing, because it's also multiplication. So you end up with having one signature, even though those multiple signers. So you have just one signature verification instead of, if you had 1,000 signers, 1,000 signatures to verify, you know. So that's an interesting aspect. Okay, let's go back to the code. So I feel like, yeah, I feel like I'm just talking to myself. Now we have this hash to curve here, and we probably have it now in our verification. Where is it? Oh, here we go. And we use that here to verify signature, right? Let's test, where is the verify signature? Keccak. Oh, that's a copy of the other thing. Okay, because we use it Keccak here. Okay, and verify signature, hash to curve. Yeah. Verify signature inner. Get those key and signature. Hash to curve. Miller loop. Okay, so this Miller loop is this E thing. Well, it's actually the whole thing here. So you have as well final exponentiation, and then check if it's identity. So that's the whole equation. So we just do it here in this few lines to check the signature. Okay. Okay, when we check signature, what do we do? When we check signature, where are we? Oh, here we go. Verify signature call. Verify it's a boolean called bool. Okay. And that returns okay or error if it was false. That's all. Good enough. I accept this code from Codex. And then what we do? We take the hand from table, and this hand, what we do with the hand? We set the pot size. Why do we need unsafe here? Set len. Overrides vector length. But because this is storage vec, okay. I see. But why is it unsafe? Is it it is unsafe. Any storage vec has unlimited capacity, so all lengths are valid. Yeah, because vec on blockchain, the way vec on blockchain works, it's not really a vector. It's all those storage structures on blockchain. It's either primitive type, and all the primitive types that are on blockchains are all U256. So it's kind of, blockchain has this ridiculously simple, slot architecture. So everything on blockchain is stored in U256, so 256-bit slots. Whether it is U8, U32, U64, U128, or U256, everything is stored in those 256-bit slots. And if you have U8, then, you're wasting many bytes, right? You're wasting many bytes. So 16 bytes, 32 bytes, right? 32 bytes, so you're using 1 byte, and 31 bytes is just unused. So that's how on blockchain you would store U8, which is wasteful. The other data structures like mappings and vectors, they are just kind of like database, kind of like mapping from key to value, key value mapping, and or like Redis. So you have key, you have value, and the difference between mapping and a vec is that vec uses integers as keys, right? And you'd expect in vec those integers to be continuous. So if the length of the vec is defined to be, say, 10, you have all the elements from 0 to 9. But this isn't exactly the case. This isn't even theory. the actual way this works is len is just another slot, which is U256, and this vec has some number of U256 slots. Now, it actually doesn't have them until you write something to them. So if you say, I want to have a vec of len 10, you don't actually allocate 10 slots. You simply put 10 into, see, this will just put 0 into this U256 slot saying what the vec length is. And then if you actually write to this vec, okay, so this thing says grow, right? So what this does is just takes the length of this vec, and at that index of the length, it sets the value, and then it sets the length to +1. So that's what this will do. So the length is a slot, and then this will just find a slot associated with this index 0 in this case, and then 1 and so on. So we could equally have mapping and put numbers into mapping and have length as a separate field. So that would be practically the same, I believe. The difference with vec bytes, actually bytes is different. Right, this is different. The bytes are taking also U256 slots, but they're kind of like bookends. So bytes, when you use slots as bytes, then the length of this byte stream, will be divided by 32, and this stream will be stored in this number of chunks, which are 32 byte chunks, plus one more chunk to store the bytes that didn't divide by 32. So you would end up having multiple slots storing them anyway. But yeah, that's kind of like how it works, right? So as far as I know. Maybe I'm wrong, because this is Rust Stylus and it's compatible with EVM, but it's compatible at the interface level. So that will be this. And the execution level, so what actually happens when you do cell bytes. I think it still has to do store, but the thing is that the VM on which this works, this isn't EVM, this is WASM WebAssembly VM, so maybe it works actually differently, maybe it's more optimized. I did not dig into this that much. So treat this information as a hint rather than proven. Okay. Now the verification. So what happens next? How we set those values on the hand. Chiefs balances. What are we doing? Index and balance. Because we need to do players index. Chiefs remain balance. Okay. Contract looks okay. So, oh, I need this readme. The reason I need this readme is because I'm unable to remember those things. I created the things, and yeah, or I asked Codex to do them, but I don't remember what I asked. That's the thing. I really never remember anything. That's why I need to have those readmes. So maybe I have bad memory, ADHD memory. I tend to not memorize things that can be written down, I think. So yeah, because It's going to be written down. Oh no, verify signature is not 26 kilobytes. That's not great. Why is it so big? And settler is 24 kilobytes. We don't like that. We don't like this. Why did this grow so much? We need to see this is the type of problems you face when you develop on blockchain. This will not deploy. This contract won't deploy. And I don't understand. Settler doesn't do that much stuff. What does it do? Keccak. It shouldn't be doing Keccak. It should be doing native Keccak. Where is Keccak? Let's not do Keccak. Oh. Let's do self VM native Keccak. Oh. Ta-da. Okay, let's ask hey, it's the contract got a leak. Let's not use Keccak. And instead let's use self VM native Keccak. That should solve the problem, I hope. So it would be actually great if Node itself had more native functions. I think some of them are called precompiles. They can be added. It's in things are written in Golang. So you can develop those precompiles for your node if you want. But I'm running Nitro Dev node, so the prepackaged version. Yeah, so let's see what's gonna happen. I can see that my live stream isn't really exciting, but you see, this is the thing. There's nothing really that exciting. To develop a solution, it takes time, and the point is, I think, of this live stream to show you the approach, you know, that actually takes time and gets into an actual working solution. Because you see, once we do this, I hope this will be the fix for this problem, and I hope we will be able to deploy this. So yeah, so it's very easy in Rust Stylus to go outside of this permitted 24 kilobytes contract. So it's really, really difficult to make it what is this? Why are you're supposed to I think Codex didn't get my instruction. Yeah, good news, but you're supposed to call native Keccak as VM method. Trying to be smart. I don't want it to be smart. I want it to be executing my orders. Come on, give me what I'm asking. Where is this? It would actually be faster for me to write it myself. But the reason I'm actually not doing it myself is because, you see, there's this little bit edge cases. What does it work in tests? Do I do the change here? Is there any other places I need to do the change? So yeah, I prefer if Codex just goes through code but I know there is only two places actually. This is just this one and this one here somewhere. So yeah, I don't understand the need for this. You don't need to do this. Just find this. Okay. And test VM. Yeah, so Codex is just annoying. Let it do the job. Let's see how much usage. It's taking 1,000 years to do simple thing. And yeah, I mean, okay, I want you to just stop doing it. I do it myself. You know, I just don't want this piece. Self VM native Keccak. That's all. I don't want this. Okay. Target arc. What's this? If not was other primitive Keccak. Well, if it's test, why the hell do I need this? Other primitives Keccak 256. I don't need any of this. Do I? VM Keccak. No, I don't. I totally don't need all this. Settlement signature digest. Okay, there is no self in here. Ah. Of course. Because it's not a method of private poker settler. Okay, I just leave it the way it did it because it messed it up, and let's see if it's taking less space. So then maybe. But it should be self VM. Should be self here. We should put that into this thing. No such method. Yeah, of course there is no such method. Why is it so important here to okay, I don't like this. Okay, I don't want this. I don't like this. I want it going. I don't want this. I want it to be my method here. Settlement signature request. Who's doing this? Oh, and we need to call self on this. That's it. I'll just stick it in the impl of private poker. Oh. Over here, self. Okay. Now we can do self VM. Oh. Now we need to okay. And now we need to do this. Test VM. How do I create this? How do I get test VM? Need to import something, no? Of course, because this, no, I'm not gonna say too much. No. Features, stylus, test. And now we can. Where's test VM? Is it new? Something like that, no? Oh, ta-da! Now we can do new. Oh, we don't want new. We want from VM. Is that what we do? Okay. What are we doing? Scripts, check, contract. What is this on private poker settlers? Oh, Jesus. Check. What's going on? Fixed bytes 32, expected U32. Okay. How about like this? Will it magically into itself? It needs to be intoed. What is on? Slice? Is there a slice? Oh, a slice. Here you go. What does it give us? U8. No, because what does this thing need? It needs add U8. And this one is it is slice, no? Oh, return value, is it? B256, oh. Okay, so this is correct. Encoded, what is encoded? Evacuate. Okay, and this is at U256. There you go. Does this work now? Okay, it does work now. Hooray! Do I need to do this? Or can I, for example, use, I don't know, let's see what kind of, with Rust you never know what you can do. Oh, ampersand. Yeah. I don't need a slice, I can just do this. Usually it works magically. Okay. I mean, I'm always surprised, like, there was a joke about Bjarne and the space operator, right, in C++. So one operator, like, there was a whole specification, I think, of adding to C++ overload of space operator. I was a little bit crazy, but if you look at Rust, I mean, there is overloads for things that you don't have in C++. We have dot and ampersand. You know, I don't actually know what asref is it. What, like, yeah, I don't know. It's madness. It's actually cool that you can do that, because then things can pretend to be different other things. Right, let's see if test works, because this change has changed the way tests work. So what we did is a fix of, because smart contracts on every Ethereum, whether it is WebAssembly VM or Ethereum VM, doesn't matter, because the limitation is the same. They cannot have more than 24 kilobytes. And the Keccak function is in library, and that library importing it was bloating the contract to be bigger, to 26 kilobytes. Oh, here we go. We don't like something. Struct VM, var_vm, mod stylus, mod host. Where are we here? Storage, common source storage. See, I knew there is something wrong with this. Okay, so common storage here. If config is not test, wasm VM. Config is not test. There's two like, because there's two different. One is in the box, another is not in the box. When feature is, but what are we building? We're building test. So what's the problem? Cargo test. Ah, I have to say test, and I did not. Here, when I'm building test, where is common? Come on, we depend on common, right? Settler cargo. We definitely depend on common. Private poker here it is. Okay. So in test, I think we need to say optional as well. Features, test, I think, but I'm not sure if I don't need to say optional. Optional only if it's here. If it's here, then we don't. Okay. Okay. from test VM is not implemented. Hooray! Private poker settler. Oh, okay, so we just need to put an ampersand here. And then we say settler. Okay. Ta-da-da. Perfect. Now it works. And we don't need this. So we need to do the same thing in the other contract. Okay. Script. Scripts, check contract. 22 kilobytes. Hurrah! We fit in 24. That's success, no? Now, the verification. The verification is same story. We need to get rid of this. We don't like that. We don't want that. Okay. Hash to curve. We want to use self VM native Keccak. Finalize self. That's a small problem. I would say. Do we need to finalize? Probably do. Now, what am I gonna do with this? Because to use this, I need to That's a problematic one. Keccak host. Interesting. So what are we doing here? If it's 132, we use this. This is kind of hacky. Okay, does this work? Codex said it was working. It's 24 kilobytes. Verify signature inner, hash to curve. Okay, so we just do this. Hash to curve. Problem is it cannot be just I mean, it is native Keccak. But it is part of we can cheat in the same way we did in the storage slot. We can just do this. This is so wrong. But I think there's no other option. We have to do a cheat like this. Storage slot with this VM. New slot taking VM as by value. Okay, I can add another one here for Keccak. I can have Keccak for this. We need just this guy. How about I just hack the VM somewhere and just make this VM. You know, maybe I can just do that. Like this. How about like this? I'll do this. Up. Throw it here. I put VM. Now in VM I just do. I don't need struct for it. No, I must use this there. Slot, we don't want slot, we just want get VM. Get VM, that's it. That's a hack, what can I do? My code is no longer borrowed from anything because I'm just doing it this way. And I just want to, oh, what is the return value here? Ah, VM. The return value is VM. Return value, this is the return value. Okay. Now, how do I? Okay. Let's return host like this. What is the problem? Must use. Why do I need to do that? Why it works? Is it for the result? What is going on here? Expected function to trigger variant found VM. I don't understand. Was it in the storage? One more time, just like this. Something is wrong. Some colon or something. Yeah, probably some colon was in the wrong place. Okay. Now we just do get VM here. Oh, and we remove this. Ta-da. No need it anymore. There we go. And now I can use get VM. Kind of hacky, but maybe it's the way to get the Keccak without destroying the whole planet. So without all this, I want native Keccak. Oh, will that work? Self Keccak hash 0. What is it doing? There is no native Keccak in VM. No. Native Keccak, where are you defined? Will you please tell me? Cryptography access. What do I need to do to get it in there? The trait. That's a trait of something. And what implements that? Cryptography access. What's a host? Then stylus core host. And this is maybe I just include this. That will work. Let's just try that. Just import this. Doesn't want to import itself. Stylus core host. Stylus core host. But where exactly? Just like that. Okay. Let's try to use this. Does this work or not? No. Because it's not. Because this is inside of it's an internal dependency, guess. Stylus core. Yeah. 090. Oh no, I could actually add stylus core. Oh Jesus. Stylus core 090. Let's try that. Stylus core. Let's add stylus core to the workspace. Okay. Cool. Stylus core is added. Now, can I do use? Will that enable access? Get VM. Wait a second. Oh, no. Ask cryptography access. No, it won't work. to untype that din. Oh, we didn't say din. Is this then cryptographic access state? Oh, if I only knew how is this implemented there. How is this native Keccak becoming part of this Stylus core host? This is trait. That's trait host. I have a feeling that it doesn't actually work like that. Okay, wait a second. Let me think about it. Maybe we don't need this actually. I don't know. What does this give us? Oh. I see. This host. Now I see. I see. This VM doesn't implement struct. Wait a second. But this is VM from Stylus SDK. So it has to implement host. Oh, struct. What's this? Stylus test. Impl host for VM. I mean, it's there. Impl cryptography access for VM. So where is the issue? That's a test, and then host for VM, and this one is also host, right? Okay, maybe I need host. Where is host defined? Let's see. Wait. I want to check something again. Not this. No. What am I looking for? This host VM. Oh, for this. Okay, so what is this guy? This guy is struct containing the host, and otherwise it's a tuple. So here the host for VM is defined for this tuple. And for VM is defined, but for this is not defined. I'm confused. access the host. How do I access the host? It's lovely, isn't it? That will work, no? Yeah. But in test it won't. So we need a reliable way of getting this host. This is just insane. Implement maybe host for this VM. How about that? It's gonna create a conflict with existing implementation. Okay, I'm just gonna bypass it. I'm just gonna go ahead and what is the type of this? Ah, type is VM. Like this. Host Stylus SDK testing. I'm gonna go crazy here. We can just get VAS VM. How about that? And we just get a reference to VAS VM. And that will solve the problem. No? And now we're gonna do like this. Well, we're gonna just do this. Oh, maybe just like that. If it's a test, then VM 0. If it's a not test, then return something like that. Oh, other way around? Okay. If not, no. No, if not test, then it is dropped. Yes. If test, then host. Ah, because the box. Ah, okay. And this is reference anyway. Doesn't like the box. Then host static. Oh, okay. It's not VAS VM, it's host. If it's test. If it's test, then we are having here then host. This we have from, well, just make it this way. I guess the return type doesn't need to be the same. Does it? Who says that it has to? And now we have to make it so that it is included from testing in case of test. Okay, and now does it work? Well, get VM host. The idea of hiding those things from the users makes it next to impossible to use it. Because I need this VM to use this native Keccak. And I need it in this structure here that doesn't have access to this guy. So that's, I would say it's problematic. But I have seen this happening when I was developing and I think this, something like that, could be structured better, but the whole idea, I think, is just to make sure we can get this native Keccak. Okay, copy from slice. This isn't slice, this is fixed bytes. So, not sure if Rust has. Okay, good enough. Okay, should be fine now. So, this is it. This is there's a problem, there is a solution, and the problem is that there is no solution because it's just too big. Digest is not working. Okay. Reset, finalize, update. Compress, slice. Yeah, I don't know. This isn't big at all, and yet it just Keccak hash. Hmm. 24 kilobytes on the TET, and it's not gonna be any smaller. It's just not gonna be any smaller. Okay, maybe there is a different way of doing it. Because maybe this VM is now adding, this is adding to the size, unfortunately. So maybe I just undo that. Oh, I don't know. Do I want to undo that? I'm not sure if it's really adding that much to the size. Anyway, this podcast is going nowhere, so I'm gonna stop it here and I'm gonna figure this out. I'm gonna figure out how to get rid of this size here. Yeah.